Hi, so the first topic for this course is a quick or brief introduction of what Stats 2 is all about and kind of differentiating it from the first course in statistics, whether you took that at App or somewhere else. Um, so the lecture material, again, will be posted in both video format like this and static um, PowerPoint slides. And the first slide will give you a brief phrase of what the topic is. And so today, again, the introduction to the course, um, followed normally by some quote that's related to statistics or data in general. This one by Homer Simpson. And so the kind of definition we're going to be using in this course for stats, and this isn't the type of course where I'll ask you to repeat this kind of definition, but keeping in mind it's the science of collecting, presenting, and interpreting data. And these kind of three parts inform us of what descriptive and inferential statistics are about. The collecting and the presenting of data would be categorized as descriptive statistics describing data. And you can describe data both numerically and visually. The interpretation of data is really what Stats 2 is all about. So when we get into the new material, we're going to be using sample data to make inferences about unknown things, unknown characteristics of a larger or broader population. And it's called business statistics, but these methodologies can be used for any field or applied to any field. And so a lot of the examples in the book and some of the examples I use have to do with business decision making, but these skills can be transferred to any field. And so in general, statistics is discovery through data. You have a question you want to answer, and you do so through kind of rigorous analysis of data. I do want to be honest that sometimes it can be boring. This is true about almost any discipline in life. You have to learn the techniques. This guy, as you can see, is drooling. It's pretty sophisticated animation. But I'll try my best to try to keep you interested. But some things are going to be arduous, and you have to kind of work through them. On the other hand, sometimes it can be totally awesome, and Greenspan can't hold back his enthusiasm for numbers in general. Question here: can analyzing data help win baseball games? And some can believe, some do believe that it can. There's what was it? Billy Beane, is that his name? From the GM from the Oakland A's, and Theo Epstein, the previous general manager of the Boston Red Sox, both subscribe to managerial decision making through data, moving away from kind of gut instinct and kind of the old or the more traditional way of making managerial decisions in baseball, and really just letting the data do the talking. And certainly successful for the Red Sox, who broke their many decades slump and won 2 World Series under the managerial decisions of Theo Epstein. And many of you have probably seen or read the book Moneyball, which talks about Billy Beane there. Now the phrase that statistics or inferential statistics is given in sports for managerial decisions in sports, sabermetrics, that's just the jargon. What we're talking about is data analysis. And so anyway, I think if you click that link, you can get some more information about sabermetrics. Can data analysis win you big money? Well, here's a real direct example from the Netflix prize, which asked for it was a contest with $1 million prize winning to a team or an individual who could improve their algorithm for recommending movies or television shows. Many of you, I'm sure, are familiar with Netflix. You get to watch films or television shows and then you can rank them. And then from those rankings, an algorithm is used to give you recommendations. And then after you watch those recommendations, you rank again. And what Netflix wanted to do is improve the likelihood that you would enjoy the recommended movies that they give you. And so you could click there and look at the winning team's statistical analysis. Now, much of that is going to go well beyond what we do in this class, so don't try to understand it. But the intuition, the premise, I think, is easily understood. So the two course objectives. First, we're going to go through some fundamentals. So make sure everyone's on the same page. I think that's important. But what we want to walk away with at the end of the semester, the end of the session, is to understand how to do hypothesis testing of both means and proportions. Okay, two statistics, mean and a proportion. We'll do different variants of hypothesis testing. And the second goal, very simply, is we want to learn how to do regression analysis, which is a nice tool that shows us correlation, but also measurable changes, and on how one variable tends to change in response to changes in another, or in another set of variables. All right, so I'll go over some examples. In terms of the population tests, one simple example, and one that I usually do with my face-to-face classes, is to test the population proportions of, or whatever Mars claims are the proportions of the M&Ms they produce by color. So this is from their website, that 24%, for example, are blue. And so we could take a sample of M&Ms, calculate our sample proportions, and then test them against these manufacturing claims. A test that we can't do in class, but a consumer interest group could certainly do, is testing manufacturers' claims on the average miles per gallon that the vehicle gets. In this case, a Toyota Prius, the hybrid, which miles per gallon is an important attribute for people purchasing a hybrid vehicle. And so a summary fleet of Priuses could be driven under different conditions and times and steepness, and come up with an average miles per gallon and test that against their 55 miles per gallon manufacturer's claim. And I'm sure tests like this are done for consumer interest groups. The question on average, which country is happier, the United States or Canada? Notice the difference in this kind of question. This, in comparison to the previous one or the previous two, is that we have a number here, a numeric value, 55 miles per gallon. We take a sample data of a sample set of vehicles, come up with their average, and test it against 55. In this question, where there's no numeric value, we're testing relative to another population. So we're saying, are people in the U.S. happier than people in Canada? And so it's just an average index that the United Nations Human Development Index produces, and we'd like to compare those two to see if there's a statistical difference between the two. And so that's obviously just one example of where you could apply this tool, and we'll learn how to do that. Here's a graph that's more sophisticated than we'd need for our regression analysis, but certainly all of you have heard of the seeming relationship between the Earth's temperature, the Earth's mean temperature, and the carbon dioxide emissions in the CO2 emissions in the atmosphere. And the reason that many scientists believe that this is a product of carbon emissions is through data. And of course, there's caveats to all data analysis, and we'll learn them as we go. But a regression analysis could be used, and is used, to see how temperature changes in response to carbon, and of course a whole host of other variables that you'd need to control for. All right, so that's a regression example. A very simple regression example from previous stats course data is Quiz 6, which comes right before Exam 2 and Exam 2 grades. And on the vertical axis, you have exams out of 100 points, quizzes out of 10 points, if you recall from the syllabus from the last video. And so as the quiz grades, as you go from left to right on the horizontal axis, you can see that there is this relationship, at least, to going up from bottom to top on the vertical axis. And it's not perfect. Of course, you can see this person who scored a 2 on the quiz scored probably a 90 on exam 2. So that person did fine without performing well on the quiz. But you do see this trend moving in the towards the upper right direction. So you'd see a positive trend. And regression would fit a line through this data. Very simply, is that's what we get. That's what we get. What we call the best fit line, and we'll describe that. And the slope of that line would tell you the change in your predicted exam grade given an increase in your quiz 6 grade. Course website, you can follow this link. However, if you're watching this video, you've successfully accessed it anyway. And finally, the first topic, or topic 1, it's going to be fundamentals. There'll be a number. It's not going to all be condensed. All these fundamentals aren't condensed into one lecture. I have many slides and video pairs for all of these. But here's a breakdown. Chapters 1 through 3 in your text, and almost any text, but the Doan and Seward text for this course, are pretty basic. And you've likely retained most of that information, hopefully, from Stats 1. It's really about like how to sample data and make sure your samples represent the population of interests. And this stuff I'm just going to take for granted. Okay, that every time we have a sample, it represents the population for our interests. All right? Now, Chapter 4 we get into, and I'll cover in detail. And Chapter 4 is descriptive statistics. All right? Talks about the empirical rule at first. Talks a little bit about the normal distribution. The empirical rule is part of that. But it also talks about the measures of central tendency, like the mode, the median, and the mean. It talks about variance and standard deviation, which is our chosen measures of variability in data. And so that's an important chapter to concentrate on first, and hence the star of the asterisk. 5 and 6 are chapters on probability. We will be using probability throughout the entire course. Okay, probability. We never leave ideas of likelihood or probability. However, the questions in chapters in 5 or 6 are somewhat specific, and in some cases not particularly relevant to hypothesis testing and regression. So I don't think that you should concentrate on those chapters, but you should concentrate on chapters 7 and 8. And that's why this last bullet point is in red. Red meaning really important. Caution, Chapter 7 is on the continuous probability distributions, specifically focused on the normal. And chapter 8 is the most important chapter in the entire textbook, or in any textbook for statistics, or maybe even any textbook ever. That might be a stretch. But chapter 8 is on sampling distributions. And it's tricky. A lot of it is theoretical. Okay? But the point is if you don't understand chapter 8, you're going to have a hard time understanding chapters 9 and 10 and 12 and 13 and basically the material for the rest of the course. All right, so chapter 8 is fundamental, and 7 is the precursor to it. So these two are important. Start in chapter 4 and then spend the rest of your time in 7 and 8 to get caught up. All right, and that should do it for this video.